x-axis?
Yeah. And there's my curve, there's my tangent, hits the x. I did it hit?
Mm-hmm.
All right. This was Newton's idea. He says you make a guess, and then you immediately draw a tangent line from that point. You see where it hits the x-axis. Kaboom. You consider that number, and you use this x value as your next guess. And so what's going to happen is, this is what's going to happen. We do this. All right, 1 was not the answer, right? Tangent line. Psh. X-intercept of the tangent line. This will be our next guess. So watch this. It'll be like this. That'd be the x value right there. And then he goes, repeat process.
Mm-hmm.
From this point, everyone, this would be our next guess. What do? You draw what?
Tangent.
Tangent line. All right, I'm going to do it. Am I getting closer? I'm trying to figure out that what? That point right there, right, Amber?
Mm-hmm.
That's what we're trying to get to. Look what I did. I do. You make a guess. Tangent line there. Ooh, it got close. Repeat process. Now what? Use this x value as your
And hit the
next
curve.
guess. And what would happen? It's probably getting really tight now, isn't it? Well, look. Then you do what? Tangent line. You'll keep doing this until you what?
Hit
You
the-
get this answer accurate to like 6 or 7 places. Isn't that cool? It's the idea. Just keep having tangent lines head towards the x-axis. Brilliant. And then if the tangent line's under here, what's the idea like? Draw it this way. And then you make the next guess the same way. Do you like that, Amber?
Mhm.
That's his idea. I think it's brilliant. You'll get there immediately. You'll get there pretty quickly. But it does take a bunch of what? Iterations. You follow me? It's going to take a bunch of steps. But it's all about tangent lines. And to do that, everyone, how do you find tangent lines and curves? You need the slope of the what?
the-
Tangent line and curve. You need calculus to do this. Isn't that cool?
Mhm.
So let's get started. This tangent line right here, this first one. How do you get the equation of that tangent line?
3x squared plus x.
All right, and we'll finish this chart in a second. Y minus y1 equals m times x minus x1, right? Which one's the derivative?
M.
M. That'll be the derivative. Now, can we just write down the derivative? Because it's going to be the same throughout this whole math problem. Now, if this is y, right here, what's m going to equal to for the y prime? 3x squared plus, does everyone agree that'll be slope of tangent line to any curve? All right. So now, what was our first guess? 1? So what would be the slope there? What would be the slope at
4.
that point?
4.
Yep. 4. What's this y? All right. Y equals 4x minus 4. What's plus a 1? What do you get?
4x minus 3.
So far, so good? This is Newton's idea. Do you like it? Isn't it brilliant? Tangent line. Shh. Find the what? What's that called? An x-intercept. Oh, go ahead, Josephine.
I'm confused, like, what is that little sheet? So,
You talking about the table?
yeah,
We're going to finish it out in a second.
but like, what step are you doing? Because
Oh, I'll show you in a second. But I want you to, on the side, to talk about this, because we got to make sense of what this line is, right? I want you to see, like, what involves. There's the equation of that what? That line. I'll get back to that, Josephine. Here's the equation of that line you drew, right? I mean, that's the tangent line right there, that first one. But what I want you to focus on is Newton's idea. Okay, so what? Josephine, we drew a tangent line, right? But what was his idea? Once you do the tangent line, what point of that tangent line was important for the next guess? The point, and we'll get back to, I know that little chart kind of helps. It makes this very easy to do. But he goes, the x-intercept of this what? Of this line. Now everyone, how do you find an x-intercept of this tangent line? How do you find x-intercepts?
Y equal to 0.
You set y equals 0. So Josephine, what we'll do now is this idea. Here's the equation of that first tangent line. But to find that point, that's called an x-intercept. To find x-intercepts, we have to set what? Y equal to 0. So we're going to take this y right here and set it equal to what?
0.
0. set that to 0. And solve for what? X. Now what do you get?
3/4.
Cool. And this is called the what? It's x, but I'm going to put in quotations. That was the what?
X-intercept.
The x-intercept. And Josephine, we will finish out the table. I want you to see what that'll make it very elegant, very easy to work out. But I want you to see his concept. It was like, okay, you do a tangent line. Great. Then what do you go to? Next step? It would be the x-intercept. Then you'll use this value right here as your next what? Your next guess. You follow me?
Mhm.
And then you plug 3/4 into the equation to see if it works or not. If it doesn't, no biggie. You record the x and y coordinate, and you're off doing it again. Does that make sense? So I'm just going to put right here when this would be the next guess. Because right there, when that's x equal to 0.75, isn't it? Now, what would be that point on the curve? Now, you're going to have to use your calculator probably to put 0.75 cubed plus 0.75 minus 1, right?
It's 0.171875.
So, Josephine, before we fill out that table,
I lost you at 0.75.
all right, you know that x-intercept's right there, right? 0.75?
Oh,
Right now, this was his idea. Oh, and it's brilliant. Josephine, he wants you to take that number and use it as your next guess. And like we did before, how do we guess? Make sure to see if it works or not. We plug it into the what? Into the equation. So Josephine, plug 0.75 into x cubed plus x minus 1 as an x value. What's that point on that curve? Don't worry, it could be some long decimals. We'll see. What's 0.75
0.17.
cubed? So we're doing 0.75 cubed. 0.75 minus 1. And what do you get?
0.171875.
Ooh, thank you. And we're all largest. 0.75 comma 0.875.
171875.
And these can start getting long. Go ahead, Kayla.
Because it's 3/4, is that why you did 0.75? Or is
That's
it-
right. And you know why?
Then
Because
it doesn't
eventually,
say it's at 0.75.
and after just like 1 or 2 steps of Newton's method, these decimals start getting really what?
Smaller.
Yeah, then they get longer and longer, like out to 8 decimal places. So Kayla, no matter what, I know it was a nice, neat what? 3/4. Expect that every time you do a Newton's method problem, to write them as decimals, because within a heartbeat, in a couple seconds, all of a sudden you're gonna get numbers like that. Look, 0.171875, you're like, I guess I could write that as a fraction. But you might find it better to just write it as what? In decimal format. But hey, this is the idea, everyone. And so our next guess is to try 0.75. But everyone, after one run of Newton's method, this is pretty cool. Notice this is getting closer to 0, isn't it?
Mm-hmm.
That's the idea. And you just keep doing this over and over. So that's why it's good to say, hey, this is going to get sloppy after a while. So it's good to keep a nice coded what? Grid going. Where you go, all right, what do I have to do? I have to get the slope. Then I have to find the x-intercept of the what? Tangent line.
Mm-hmm.
So that's what we're going to do over here in a second. Go ahead, Josephine.
I was just wondering, this x flat equals negative y over n plus x.
I'm getting to that.
Okay.
Gosh, just be patient. Alright, is everyone okay with this? Oh my gosh. Alright, so this is the x-intercept of that tangent line. So what's really in this process, we will make this more smooth. We're going to make a table chart like she's talking about. Because the key thing is, number one, we want to be able to get the what? The slope of the tangent line. What was the slope? 3x squared plus what? 1, right? And then what's important next? The x-intercept of the what? The tangent line. So I think, can you help me do this? Can you help me invent this? And Josephine, you'll be a part of this.
Yeah.
We're going to create our own formula for m in this equation if we're always finding the x-intercept. Okay? So hey, and we're going to do this off to the side, all right? Hey Josephine, so let's look at this equation right here. Keep it in m. If we find the x-intercept of this thing every time, isn't it on an x-intercept, the y value is always what? 0. So when I want you in your notes, just to take this thing before you fill out the table, and would you set this y1 equal to 0? And would you solve for m?
Yeah, 2.6875.
Can you solve for m in that equation? Let's see what we get. Right? Or in this case, as you'll see, everyone, I apologize, solve for x. I apologize. I want you to solve for this x-intercept here.
Which one?
For this one right here, which would be this x sub 1 right there. And you know what we're going to call it? We're going to call it the x-intercept. Or you can just call it x sub int. Will that work?
Uh-huh.
And I want you to solve for it in that math equation. So what's y minus 0? What letter?
Y.
Alright, that'd be a y. And you got a what? X minus, but let's call this one right here, Josephine, because that's really going to be the x-intercept. Let's call it x sub int. And now your question, what would you divide? Alright, let's divide by m. We're getting closer. Now how can I solve for that? I'd have to subtract the what?
X.
X. Alright. But how do I get that negative on that other side?
So you have to do x minus y over m.
I love it. But hey, so far so good, Josephine? Oh, love this. So and this is what we'll do, we'll make a table out of this, because this is what we need every time. We need the x-intercept the tangent lines, and we just need to know what the slope is. So, now when we're going to solve for x int, it's got a minus here. So let's multiply a negative to both of these.
Uh-huh.
That would make this one what?
1 minus
Negative y over m, and that'll make this a
plus.
plus x. Now what's another way to write that? You probably see how I wrote it on the table. And Josephine, thank you for being patient. Well, thank you for being patient. What's xn equal to every time? It's going to be
X1.
x minus what? Y over,
M.
and do you see it on that sheet? Actually, how did I write it? I think I wrote it in this format. Did I write it like this?
Yeah.
So what we're saying is, this is what we need every time for every what? As our new guess. So what we do is, it's nice and elegant. One column for x, one column for y. We need a column for figuring out the what?
X-intercept.
The m every time. Now what, at each point? Put an arrow here. What's the slope of that equation though? 3x what?
Plus
1.
3x squared plus 1, right? And then in our fourth column, we're going to always find the x-intercept, which is equal to, what is it? Now, we don't have to do all this work like this anymore. Let's use this as our nice table. And then when I want you to fill out that table with me, ready? Make sure that's nice and straight. Now keep in mind, you can do this with any math problem. The only thing you're going to have to change every time is, isn't the slope of a tangent line in a curve equation going to change for each curve? Like what if it was x to the fourth plus 5x or something, right? And you'd have to figure out what that slope is, right? But this whole iteration process will work every time. This is how it works. What was 3 times, now you're going to plug this in there. What's 3 times 1 squared plus 1?
3.
So now I want you to fill up this table with me. At this moment, we don't have to do this anymore. That was more conceptual. I wanted you to see it. 3 times 1, I plug in 1. 3 times 1 squared plus 1 is 4. Now go over here. What will this be? Negative, use this number. Negative 1 over 4 plus 1. And I hope you get the same number we said before. Is that 0.75? I want to make sure, Kelly, that's the same number we got before? See, this is more elegant. What I mean, it's more smooth. And we can just what? Go through this process. It's an iteration process. We don't have to keep drawing these. We don't have to keep writing out all this math.
So
What
this
we
is.
do is, can I erase this part?
Uh-huh.
Oh, and this is why, I want you to see why this equation came out.
So this is the
And we
algorithm.
just keep going. This is Newton's method. And then what goes here? Ready?
Yep.
What goes here? The
Point-
next what?
0.75.
Your next guess. So you just drag that over, and you run again. Cool?
Uh-huh.
Hey, Farad, I'm sorry, I knew you had a question.
Oh yeah, it was about what you just erased.
Oh, sorry about that. I can show you later, that will that work?
Yeah.
I'll promise to. I promise to do that. Hey, you know what's great? We now have this nice iteration process going, and we just keep going and going. That was one iteration. Let's do another iteration. Now look, I've got my new guess.
Mhm.
So Amber, how do I get this number here? I have to take this and what?
Plug it in on the original.
I plug it in there, and then what does this become?
0.17.
1875.
Uh-huh.
Yeah.
All right, now to get M, I gotta plug what into this?
You plug the
0.75. Good. So when you got your, it's gonna be calculator heavy, isn't it?
2.6.
You got your calculators?
Uh-huh.
I know it's calculator heavy.
2.6875.
2.6875. See, Kelly, these start getting long. Sometimes they go up to 8 places. We'll go out as far as we can. All right. 2.6875. Now what do I have to do over here?
Divide
Negative
y.
y in this row. Look, negative
Negative.
y. Oh my goodness. You gotta type what into your calculator. I'll let you do it. Negative this divided by this plus this, right?
And we're doing this to find.
Our next guess.
Did you get y from plugging the x intercept
That's right.
into
Into the original curve. Into this curve right here.
But you can just plug this on the calculator.
That's right. That's where that y comes from. Did you get that?
No, I got a 0.4218.
Let me check.
Add 1 to it.
E.
Did you add the 1?
I-
We can do it.
This is what I did.
Let's see, ready? I'll do it. So we're gonna plug 0.75.
Oh, I see my mistake.
You see it?
Yeah, I added 1. I set it on 0.7.
Cool.
I did 2.68.
2.6875. What I did was, there's the slope equation, right? But I had to plug in for x, this x value. This is iteration, that was iteration 1, this is iteration what, 2? Now how do I